I really enjoy playing basketball, and it's not because I'm disproportionately tall for my age or because of the camaraderie that comes with being on a team and all having the same goal. It's not because of the euphoria that I get when playing the game, with the nervousness and the anxiety and the exhilaration and the stakes of it all. As pompous as it might sound, it's the complexity. Truth be told, I really do enjoy the complexity of the game. How a player at the top of the key, or anywhere on the court for that matter, has so many options. It really is a game of decision, and I like the ability to choose. The freedom. So, as an example of this, one can pass, shoot, cut, dribble, drive, screen. As cringy as it might sound with me saying it like this, in this way, no other sport has this amount of potential action. That being said, I was also heavily invested in the idea of artificial intelligence. And it wasn't just for the future, but now. It was the possibilities that it held that had interested me so much. And then I had an idea. How can I combine the two fields? Just to give you some context as to why I was thinking about these two things in such contrasting ways, we, as in the 10th grade, had to submit our idea proposals for the IB NYP personal project. This was an 8-month project in which students would have to investigate, plan, create, and evaluate a goal that they had chosen, and whether they had succeeded or not. I was scrambling for ideas. I had so many in my head, I had so many interests that I found it incredibly difficult to try and choose only one field of study, only one concept, only one area. But I knew that I wanted it to be something which I could learn from or gain some experience with. I remember seeing past personal projects in which the students didn't really learn anything or do anything particularly impactful. They weren't passionate and there was no practicality to them doing it. And so that was when I decided to dive headfirst into a project that I really had no idea how to create and just relied on my interest: artificial intelligence. To start off in my research, I looked into how data analytics in the NBA was being done. How computers were identifying players and which were the best shots, primarily with the offense of the Houston Rockets. They used the firm Second Spectrum, and Second Spectrum uses machine learning algorithms and visual representations to classify what is happening on the basketball court and give probabilities to shots, passes, rebounds, and other statistical categories. I set my goal to be the training and development of an algorithm that would be able to analyze and understand the difference between a make and a miss when shown a live video feed. So let's take a step back. When most people think about AI's potential and its possibilities in the future, they think about Terminator, more so Skynet, HAL 9000 from Space Odyssey, and sometimes C-3PO if they're just a little bit more optimistic than the others. I think it's important to stay away from this robotical, mechanical approach that's depicted in movies, because we're not near that stage. It's close, but it's still a ways off, for better or for worse. So, just to give you an itinerary, here's how the series is going to go. In part 2 of the series, we will be discussing the categorization of AI into subcategories relating to its functions and levels of development, what a basic algorithm should be able to do, its inputs, the black box that it runs through, and the output. This is just going to be a general overview of the topic with definitions and such to continue forward. In part 3, we will further endeavor into machine learning with the explanation of deep learning and neural networks, i.e. what they do, how to adjust them, what are weights, biases, parameters, hyperparameters, etc. This is how most tasks related to big data are being trained, as it is the most accurate method and structure developed until this point. We'll also be looking at some other models and some other methods for training, such as the K-nearest neighbors classifier and the genetic breeding model. In part 4, we'll go over some of the common implementations in daily life, such as YouTube, Google, Amazon, all of these things that we just normally interact with. We'll also be looking at how to think of these in the terms that we have previously defined with neural networks in these areas. Part 5 will be about the implications of AI use. This is the more philosophical side of us really using machines that think like humans. They'll be able to complete fairly simple tasks with a high degree of accuracy. That's what they're able to do now. But what will happen when it has a theory of mind, the ability for it to be aware and conscious of other people's or computers' beliefs and desires? For example, when presented with thought experiments like the trolley car problem, who will it choose to save? Will it pull the lever? Will it decide to save itself, the one human, or the many? Where will it get these moralistic beliefs? Will they be absolute? Who's going to design them? What will happen when an AI becomes super intelligent and supersedes humans in every way, physical and metaphysical? This will probably be the longest and most interesting video in the series for you ponderers out there. Lastly, I will talk about my own process in this project and my opinions on all of these possibilities, how I think AI will influence the world in more practical terms like the job market with autonomy, how the road ahead of us will look, and not just as individuals, but as a species when confronting our possible robot overlords. Just kidding. Well, maybe.